Good morning, everyone. So today we'll be looking at chapter 9, probability of combined events. So in this chapter, we'll be focusing on two things, which is dependent events and independent events, as well as mutually exclusive and non-mutually exclusive events. You will learn on how to differentiate these two events and perform calculation and problem-solving questions involving them. Okay, as well as at the end of the chapter, we'll be looking at the application of probability of combined events. Okay, so let's start. Okay, first of all, understand what is the meaning of combined events. Combined events is basically a combination of two or more events in an outcome. For example, if here, what are the possible outcomes of two pupils playing rock, paper, scissors? So I have pupil number 1 and pupil number 2. So pupil number 1, when playing rock, paper, scissors, what are the possible outcomes that pupil number 1 can show? So this pupil can either show rock, paper, or scissors. Pupil number 2 also has the same possible outcome. The pupil number 2 can also show rock, paper, or scissors. So we can list out the possible outcome of these pupils using two methods. First method is known as listing possible outcome. And the second method is known as drawing a tree diagram. Let's look at them one by one. So, for listing possible outcome, method number 1, we know that each of the pupil can either show rock, paper, or scissors. Okay, so pupil 1 can show rock, paper, scissors. Pupil 2 can also show rock, paper, scissors. So, their possible outcome, we will use the symbol S referring to sample space. Okay, sample space merujuk kepada keseluruhan possible outcome yang boleh diperolehi dari sesuatu soalan. Okay, dari sesuatu probability. Okay, we use S. So S. So sample space. If first pupil show rock, second pupil might show rock as well. So we have first pupil rock, second pupil rock. If first pupil show rock, second pupil might show paper. If first pupil rock, second pupil might show scissors. Now, first pupil might also show paper. So paper, second pupils might also show rock. So first pupil paper, second pupil rock. First pupil might also show paper and second pupil might also show paper. First pupil show paper, second pupil show scissors. Okay, and then first pupil might show scissors, second pupil might show rock. And then first pupil shows scissors, second pupil show paper. And then first pupil shows scissors, and then second pupil might also show scissors. Okay, so basically we are listing out all the possibility of the outcome of this game. Okay, setiap this game here, the rock, paper, scissors will have this probability, right? Because we don't know which one will the pupil show hands. Okay, dia akan tunjukkan kita tak tahu mana satu. Tapi kita boleh senaraikan kemungkinan yang akan keluar. Kemungkinan outcome game mereka. Okay, if I'm playing with you guys, I might also show either one of these. This might be one of the outcome. Okay, so this is our answer for the listing possible outcome. Now, what about if we draw a tree diagram? So, similarly, we'll be using the same method, almost similar. We have pupil number 1 and pupil number 2. So pupil number 1 might show rock, paper, and scissors, right? So if pupil number 1 shows rock, pupils number 2 can show either rock, either paper, either if pupil number 1 shows paper, then pupil number 2 might also show rock, paper, or scissors. If pupil number 1 shows scissors, then pupil number 2 might shows rock, paper, or scissors. So our outcome is either pupil 1 rock, pupil 2 rock, pupil 1 rock, pupil 2 paper, pupil 1 rock, pupil 2 scissors. Okay, second one, pupil 1 paper, pupil 2 rock, and then we have paper, paper, and paper, scissors. Okay, scissors, rock, scissors, paper, and scissors, scissors. So we will have the same outcome as the first one just now. So these are the possible outcome of the two pupils playing rock, paper, scissors. Okay, so now I've told you already that S refers to the sample space, or also known as the number of the possible outcomes. Okay, so in this question we will have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 possible outcomes. Okay, therefore our number of sample space or number of possible outcome is equal to 9. Another formula that we can use, okay, please excuse the background. Another formula that we can use, okay, we know that S is equal to the number of possible outcome, okay, or the sample space, and there is a formula which number of possible outcome is equal to the number of outcome of event A times with the number of outcome of event B. Okay, what is the meaning of event here? So for example, just now we have pupil 1 and pupil 2. Event means what are the possible outcome for each of the event here. Event 1 is referring to the pupil 1. Event 2 is referring to pupil 2. So pupil 1 might possibly show rock, paper, scissors. Pupil 2 might also show rock, paper, or scissors. So the number of outcome of event 1 is 1, 2, 3. And the number of outcome of event 2 is also 1, 2, 3. Okay, so the number of possible outcome is 3 times 3, which is 9, which is similar to the number of possible outcome that we listed just now.